Here we have an isobaric process, and this happens when the pressure remains constant as the volume expands or decreases. So here's though an ideal gas in a malleable container where the walls can move so the pressure can stay constant. So here we add heat to him, and he starts slowly expanding. As you can see, the walls are moving so that the pressure stays constant, and Noah is a happy dancer.
In isobaric process, volume increases and pressure is constant, so it can be represented like the flat line.
Here we have an isochoric process where the pressure increases or decreases and the volume stays constant. So here's Noah, our ideal gas, trying to expand as we add fire to him, as we add heat to him. And as you can see, he's trying to expand, but the pressure increases and he has a mad face because he can't expand.
In isochoric process, the volume is constant and pressure is increasing, so it can be represented as a vertical line like this.
Okay, here we have Noah dancing, representing an ideal gas. And now we'll show an isothermal process. I'm going to turn up the temperature of this room really slowly so that Noah's dancing becomes more crazy. So in the room, the pressure is slowly decreasing so that there's no more space for Noah to dance, as shown in this barometer. However, as he's expanding, the door keeps opening to let heat out so that the temperature of the room can stay constant. And since the temperature is remaining constant, Noah's doing work on the environment.
In isothermal process, the temperatures remain constant, and as pressure increases, volume decreases. So it can be represented like this graph.
Now we have an adiabatic process where no heat is transferred between the system and the surroundings. And because this process happens extremely quickly, the slow-moving heat doesn't have time to flow in or out of the system, and the system is also well insulated as this door doesn't open. And now we're going to increase the pressure really fast, and let's see what happens to Noah. Noah decreased his volume so fast and the temperature went up, and then suddenly he died because the temperature went up so fast.
In adiabatic process, it is much like isothermal process, but the temperature change, so it's much steeper than isothermal process.